I couldn't really decide on what topic to talk about, so I ended up giving an overview of what we're doing at the IDS in corpus linguistics, and that also with some looking back on the tradition there. But also going into ongoing research there. So I hope there will be at least something for every one of you, and I think I'm going to talk about like 40 minutes or so there, so at most, so that there would be time for questions, and I will be able to go into more details about topics that may be of interest to you. So, as promised, after a brief introduction, I'll go into corpus design issues, then distributional syntax and semantics, say something about our new corpus analysis and query tools, and end up with a recent development in comparable corpora at Mannheim. Okay, the Leibniz-Institute for the German language that I'm working for is the central scientific institution for the documentation and research of the German language in the present and its recent history. It was founded in 1964 as a civil law foundation. So we also celebrated our 50th birthday just 6 years ago. And it's one of the 89 institutes of the Leibniz Association. It's like Max Planck, but well, what they have in common, these Leibniz institutes, is that they are financed jointly by the federal government of Germany and our local state, Baden-Württemberg. We have about 133 employees and 76 students, and about 100 real researchers and 30 people working in the administration. And the institute closely cooperates with the University of Mannheim, which is only 200 meters away, and the University of Heidelberg, which is about 20 kilometers away. Yeah, this is what the main building looks like, and I'm working on the top floor, so I can appreciate the sun on the roof every day. We don't have air conditioning here, but it's 10 o'clock now, and it's quite cool now. Corpora at the IDS already started in 1964, the first corpus building project, and the first corpus was actually published in 1969, of course on punch cards at that time, and was called the Mannheim Corpus 1. And we still have it, and we still have it in our corpora. And in '83, the first query software was introduced called 𝗲𝗂𝗋. And in '92, the first analysis software was more or less online. It was called Cosmos 1. And I don't know if it was still available via Gopher or already via HTML, but I think it was at least online in '92 already. The corpora at the IDS amounted to 20 million words at that time. So we have quite a long history of using corpora and also of making them available to other researchers. So these punch cards in the '60s could also be used, of course, by other searchers. Yes, I can already see one question here. Okay, I'll answer the tool things. It was a question about the tools. I'll try to answer that later. Okay, so yeah, we have a long history of using corpora and also of making them available to other researchers. What I was always wondering is how corpus linguistics in the mid-'60s, how this could come about, and how this IDS was founded already with a corpus building project. And my question was answered only with the festive publication, with the Festschrift for the 50th birthday of the IDS. And shed some light on it. Apparently, innovation was an important argument for the foundation of the IDS at that time in a technological sense, because upcoming computers were there and artificial intelligence was already a hot topic at that time, but also in a political sense. So to make German linguistics less susceptible to ideological influences. So this aim of strict empiricism had a strong political motivation also in '64 already in Germany. And one more reason is, of course, that the shift of interest from performance to competence only arrived in Germany 10 years late in the '70s. Otherwise, this probably wouldn't have happened. So corpus linguistics now at the IDS, it's the main modus operandi for all so-called program areas. So the research in the IDS is organized in program areas, one of which is the corpus linguistics program area I work in. But there is also another a program area on oral corpora. So I mainly deal with text corpora, but of course in the text corpora we also integrate transcripts of spoken corpora. So the corpus linguistics program area now is because everybody's doing corpus linguistics, at least in applied corpus linguistics, is now mainly responsible for the foundations and basic research on corpus linguistics. So it's a kind of meta research on corpus linguistics, so that's why it's also quite convenient not to show you real applied corpus linguistics this afternoon. So we provide corpora, most notably the German reference corpus DeReko, and methodology as well, mostly corpus-driven methodology, and also general research tools to the entire community of German linguists. And with respect to concrete corpus linguistics application, we involve that typically only for proofs of concepts, or otherwise, of course, in cooperations with other projects at the IDS or from anywhere. And corpus linguistic group has 8 researchers, including me right now. So, as promised, I come to my first content point, corpus design. As I said, this German reference corpus DeReko was already started in '64. It aims to serve as an empirical basis for the entire synchronic German linguistics. And for that reason, it also has to be sufficiently licensed with more than 200 agreements with rights holders. So this is not very nice work, but it can be done. And this corpus building project is just one full-time equivalent or so. So it's not that bad. DeReko samples the current use of written German. Current means since about 1956, which is just after the post Second World War area, but also contains other works like Goethe and so on. And contains a broad, and it's continually expanded. So this corpus building project is really a standing project, and we're really continually sample the use of German in DeReko and have about 2 releases per year. Also, one thing, it provides several part of speech dependency and constituency annotation layers for the whole corpus. So probably the most distinctive feature of DeReko is what we unfortunately called primordial sample design. So unlike other reference corpora or national corpora, DeReko does not strive for any balance, because we think that balance depends on the research question and of course on the targeted language domain. So questions like, what is the language domain I want to investigate, or what is balance? Is it 20% newspapers, 30% fiction and 30% oral, or is it 50% newspapers and 20% whatever? This is a bit arbitrary, and these questions should not be answered by the corpus or the corpus provider, we think, but by the researcher herself. And the researcher should be enabled to draw stratified subsamples from this primordial sample that are as representative as possible with respect to her research question and targeted language domain. So what we're trying to do is that people can define their own corpora based on DeReko and based on some metadata. For example, you could define a corpus with Swiss German newspapers and novels from 90 to 97 or something like that. And you could also give more metadata restrictions to restrict the corpus to just the language domain you would like to investigate. Or you could also make a big corpus with whatever balanced proportion you would like to have. So the advantage of this primordial sample design is optimal reusability of the data for the maximum amount of potentially relevant research questions. Because you can not only use the corpora as reference corpora, but you can also use them as special corpora for language varieties and so on. And compare Austrian to Swiss German with, or you can compare different periods of German as well. What's also important for the building of the corpus that relative population sizes of individual strata are completely irrelevant. What matters is, so it doesn't matter that we have 99% newspapers, but because you can, as long as we have enough fiction or computer-mediated communication and so on, you can build your own corpus with completely different proportions. And we have an optimizable cost-benefit ratio for the corpus expansion because we don't need to reject corpus data that comes for free. So if the head of an archive of a large German newspaper calls me and offers me his whole archive, I don't have to say no, but can you offer me your private email correspondence? But I can just accept it and get it for free then. And people can use it or use it not. This design is also, of course, connected to some drawbacks because there's, of course, a high technical effort to support the construction of virtual corpora. I'll come to that back later. And also to guarantee their persistence so that other people can reuse your corpus and can replicate your studies or verify your study you've done on the corpus. And also a drawback for the user maybe is that the user himself has to think about his language domain and the sample and whether the sample is representative for the language domain he's trying to investigate. So he has a bit of work to do, but he can also, of course, use the whole DeReko if he wants to. So why haven't the BNC or the Mannheim Corpus 1 gone this way? I think the advantage of this primordial sample design only comes into effect for standing projects. Because you can't say I'll sample novels only in 10 years because in 10 years they will be published as EPUBs and I don't have to do any optical character recognition anymore. When you only have a 3 years project, that's not possible. And of course, you really need a large corpus because otherwise subsamples would be meaningless if you don't have any data that populate this strata you want to look at. So technical conceptual requirements were probably not available at the MK1 time back in the 60s and probably not for the first BNC as well. And in that time, in the 80s or 90s at least, also the cost for different text types were pretty much the same. Whereas nowadays, our costs really vary between 0 and infinity for another issue of an already converted newspaper. it doesn't take any effort, but for some sources, I don't know, for some publishers, we know that we won't get any license ever. And so that's the reasons. So now the criteria for extending DeReko is where the basic aim is maximization of size and variation concerning the potentially relevant dimensions like text type and so on. And of course, the demand by IDS internal or external projects and users. And we also have to count in the supply. We try to get what is there, what is offered by external projects also that develop their corpora. And if they finish, it's nice if they can give us the data. It's nice for them and it's nice for us as well. And of course, we have to minimize the costs for acquisition, exploitation, and follow-up costs. And we have some long-term strategies and predictions, like waiting for old novels to come out in electronic form rather than digitizing them ourselves. So the DeReko license acquisition, I can make this short. I think we typically do this in waves. So we address like 100 rights owners, publishers, to get out at least, I don't know, 1 to 5 license agreements after all. So that everything stays a little bit plannable and has at least some success. So thanks to all these, and this is also part of our license agreement that I have to show you this little advertisement. And yeah, thanks to our license donors for giving us their data and letting us make it available to other researchers. So thanks to this, we really could grow DeReko quite a lot in the past years to almost 50 billion words right now. It's a 46 billion words right now, growing, I don't know, by 2 billion words per year or so currently. Yeah, you might think, isn't that already enough data? And I will answer no. I think more data is still better data, ceteris paribus, and DeReko will never be enough with otherwise constant parameters, because the bigger a corpus is, the more reliable statements can be made about different phenomena, and particularly rare phenomena. And we know that language is characterized by its large number of rare events. So the interesting things are really typically in the very long tail somewhere there. And rare does not only mean lexically rare, but can also be something can be rare because of a combination of conditions. So if you can define your virtual corpus like literature from the 60s written by female authors, and then you might end up with just 0 text or so, or close to 0 text. So size is really still important, and what's equally essential, of course, is dispersion or coverage of the relevant strata that you can really make use of the data and just double the data you have. So concerning coverage, what we're really quite good at is geographical coverage. So all the German-speaking areas, not just Germany, but also Luxembourg, Switzerland, Austria, North Italy, Belgium, we're really quite well covered with press sources here in DeReko. Well, since recently we also improved sparse text type like literary texts, conceptually written language, political speeches, and most notably computer-mediated communication. So we have a long series of Wikipedia included actually in DeReko, and also a quite big archive of Usenet use, if you still know that, and also some chat corpora. So, so much for corpus design. I think I can come back to this later if you have any questions on this. Another thing, we have quite a long tradition is probably distributional syntax and semantics. We've been using this, or not me, but some of my colleagues have been using this already since the early 90s, and at that time, not based on neural networks or word embeddings or whatever, but really on classical collocation analysis. So if you define a word by a vector where every vector position is populated by some association score to some other word, you get vectors for every word as well. And by doing some vector compression, you also get something which is very similar to current word embeddings. And but that wasn't interesting, of course. Interesting were the applications, and the main applications were to discover or to explore and to investigate subtle meaning differences in lexicology, and lexicography, and also the investigation into syntagmatic patterns. And the research question was always which dimension reductions and visualizations enable the abduction of promising hypotheses best. So this this kind of dimensional reduction is going on there, and visualization really serves to to make the researcher abduct promising hypotheses that he can later verify on the concordances. So I can show you this. So the open experimentation platform that was already online in the 90s is the collocation database CCDB, and you can see here just a syntagmatic analysis. It's just based on collocation analysis, but recursively applied. So if you apply just plain collocation analysis, you only get the node and the collocate. But if you apply the collocation analysis again on this pair, and you can do this infinitely if you have enough data to justify this, you can get longer syntagmatic patterns. That's what we call it. So you can see analysis of Grund, that's reason in English, and you can see patterns like I see no reason why, and here are some spaces that can be filled by different word, and some fixed spaces, and variations of that theme, and yes, it goes on with different primary collocates and the recursive collocation analysis applied to them. So this was quite fruitful resource since a long time, and it's still what it's looks like now. Unfortunately, the data is already quite old. It's from 2007 now, but you can still use this, and I still use this as well. So this is really a kind of visualization and verification platform, and this is a poster from a Corpus Linguistics conference 14 years ago, I think, or so, 15 years ago. And you can really verify your your hypothesis here by pressing the expand buttons. And yeah, I think for syntagmatic patterns it was quite nice, and still quite nice. What we've been doing and still doing as well, of course, also distributional semantics based on collocation analysis. So what I just said about this vector representation, we call them, if we get them by collocation analysis, the collocation profile of a word. And also these collocation profiles have the have in common that small distances reflect their paradigmatic similarity or semantic similarity, just like with word embeddings. So of course these are high dimensional spaces then, but yeah, we use self-organizing maps to map them on 2D maps. So, for example, I try to find some words you might know here. For example, this is boutique here, and these are the I don't know, 50 closest neighbors of boutique here. And you see some jeweler, electronics store. You see lots of different stores: pharmacy, bookstore, bakery, everything you can imagine. So this is really good for looking for synonyms and in investigating the subtle difference, because closeness here means really yeah, similar use or similar context in use. So more interesting than to look at just one word in these maps is to look at many words. So you can really use this for contrasting near synonyms. For example, here by looking at boutique versus shop, and you have on the shop side, on the red side, you have here lifestyle television, while on the boutique side, on the yellow side, you have jeweler and cosmetics and parfum and fashion and so on. So it's really nice for contrasting your synonyms. What's also nice is projecting this just on one dimension for getting something what we call semantic gradients. So you can really see, well, close synonyms with a connotation towards, I don't know, a bad connotation and a good connotation on the other hand. So for this, it's good to have just a one-dimensional projection. Current research in this area is based on neural network models and on word embeddings, because the reduction of dimensionality is more effective. The current research question for us is, how can text external variables be integrated in such models? We know that language varies with mediality, time, topic domain, and text type. And we really would like to investigate the influence of these variables on language variations. So we really would like to incorporate these variables into our models. So what we would like to do is to go from multidimensional analysis to multidimensional modeling for doing more exploratory kinds of research. We haven't really arrived at making these metadata or making these external variables parameters of the model. What we have been doing so far is to define corpus slices that we train the models on. So, for example, here we have for macro analysis of topic domains plus semantics, we have divided the corpus, the whole DeReko, into different topic domains, and we trained the models on the different topic domains separately, and cannot just have a little slider with changing the topic domain, but we also always have to use a different model here. But it's already nice to see and to get a macro analysis of the, for example, here the most typical words of topic domains and how they cluster here. Here is obviously the music cluster with rock music, funk, rock, metal, waltz, blues, and things like that. And here this is another cluster. And of course, you can also zoom into these clusters and take a closer look. And yeah, we have also done this for the factor time, where we have separated DeReko into different time slices. And it's also quite interesting to have here semantics and time and frequency change in the same visualization. And you can yeah, here you can see the change in nominalization patterns. So at least you can get a hypothesis on it, because this nominalization with ung, with the suffix ung, apparently disappeared between 55 and 2015. Instead of this, here is nominalization with Name. I don't know, but that's at least an hypothesis you can get from this, and you have to verify this in the concordances, of course, in the real corpus data. The question here, I'm wondering if the output are only collocational profiles and visualization. Is it possible to obtain simple concordances pages and word frequency lists? Yes, of course. Yes, that's also possible. I come to that later. Okay, for microanalysis, for investigating subtle semantic differences here, we still use these self-organizing maps, but now based on word embeddings, more or less. And what we also have investigated is mediality or text type caused variances. Here, for example, is the most typical words in Wikipedia talk pages in red versus the whole DeReko in yellow. And what you can see here, this Wikipedia talk pages don't cover the whole range of topics as DeReko does. For example, local news or gossip also isn't covered. But there is interesting cluster regions here with text critical vocabulary, for example, is a nice cluster of adverbs that can be used to characterize opinions on other people's texts. So this is not Wikipedia, but the Wikipedia talk pages, the discussion pages. We also, because 2 dimensions and is not enough, we've experimented with 3 dimensions, especially for this with Wikipedia talk pages in comparison to DeReko. And here you can see, even in the virtual reality space, these aggregated visualizations are always linked back to the concordances. But even with the virtual reality glasses, you can click here on the word and get the concordances, which is quite important. So it just can show this just very briefly. You can really fly through the semantic space in virtual reality, and this is actually an Android thing, and you can also use voice recognition here to fly somewhere. But yeah, we have shown this only on fairs so far, and at one IDS conference. I don't know if this really brings a lot of interesting things, but it was nice to play with. So concerning corpus analysis tools, you might think you have already seen some tools, but we have also more generic tools for corpus query. Mainly, the main tool is still Cosmos 2. It's already designed in '94. It can be used freely for academic purposes and has a little bit more than 40,000 registered users, at least, that still have existing email addresses. It has lots of features, morphological assistant, different result aggregation here to aggregate your results to time slices, and also has this recursive and clustering collocation analysis. But it was already designed in '94, so it really was time to develop a new platform, and we started this in 2011 to develop our new platform called CoRAP. And the aim with CoRAP was to develop another sustainable platform for the next 15 to 20 years, and to support an in principle unlimited amount of primary data and also annotation levels. By being horizontally scalable, that means if the system gets too slow, we hopefully can just add another machine to make it quick enough. Yes, Corp supports different query languages, not only the Cosmos 2 language, but also the CQP extension called 𝗶𝗂𝗊𝗀𝗃𝗃, which was developed for the Polish national corpus. And also ANIS, I don't know if you've heard of that, that's very good for querying syntactic annotations, constituency annotations, and dependency annotations. You can also define your, as I said, this very important concept, your virtual corpora, your subsamples of DeReko quite easily based on metadata. Right now, you can use the corpus title here. It's quite an easy example to look for Wikipedia stuff here, but you have access to all metadata that is in DeReko here. And if you don't know the metadata categories that we have, you can also simply search for a typical word, for example, for sock puppet to find the Wikipedia talk pages, and you find the metadata there, and you can send your corpus definition up to the corpus definition box here by, yeah, call it corpus by example or something like that. We also have a really arbitrary number of annotation layers already there. You can see lots of part of speech and lemma annotation layers, syntactic annotation layers, and so we really arrived at our aim what concerns this. And we have also here only, you can see constituency annotations. And of course, we can also query the annotations, and you don't have to, yeah, there's a query assistant there, of course. But what I'm more proud of here is that we also have here query by match. So if you're looking for a special pattern, like here in German means learning to win, something like this, you can just query the concrete phrase and expand the query results and click together your annotation-based query and send it up here. So this way you can formulate complex query without previous knowledge, and what's even better, while doing this, you really end up learning the query language, because you need to modify it slightly to introduce little gaps or whatever. There is here a question about non-Latin alphabets, Persian. I think this should be possible. It should be no problem. It's a Unicode-based, but I don't know what happens with right to left languages. If that's really supported, it would be very interesting. But yeah, Corp is an open source. It's on GitHub, and you can have a look if it works or not. What I'm also haven't mentioned before is that you can use this different annotation layers for maximizing recall. We know that part of speech annotations are not perfect, and the problem is always the false negatives you don't see, and you can at least make this problem a little bit smaller here by combining searches on different part of speech annotations, for example. For example, here you have a query looking for does annotated by core NLP tools as a relative pronoun, and you get 12 million hits, and if you add an OR here and add the tree tagger part of speech annotations here, you get twice as many hits. So that's really a nice thing to also to get an idea of how many false positives, false negatives you have to deal with, and how problematic the region is, or your queries are, or your research question is concerning part of speech annotations or other annotations as well. And yes, as I said, 𝗀𝗏 is open source, and it's also accessible via an R library here, and that's quite nice because for frequency queries here, frequencies over time for making plots here, it's quite easy to do. And a nice thing about these things is also that you can always click on data points here to get a corresponding query here in 𝗀𝗏. I don't get any results because I'm not logged in here, but in principle, oops, I don't get back to my slides here. Oops. Okay. So the rest of 𝗀𝗏, as I said, is also here on GitHub under BSD license, so you can try it out. However, one thing we are still working on in 𝗀𝗏 is the one-click installation. It's actually, I think, a milestone for next year, but I think the Hungarians have developed a Docker container with a whole 𝗀𝗏 running in it. So the Hungarian Academy in Budapest. There is also a Python client to access the data. And yes, I think I'm running out of time. Do I have time to mention comparable corpora, or should I rather?
Yes. I think so. Mm-hmm.
Okay, then I'll do it. So yeah, at the IDS, not only our Corpus Linguistics program area, but also our grammatician thinks that parallel corpora alone are not suitable for fine-grained contrastive research because of all these translation effects like shining through and others. And possible workarounds, of course, to use a combination of parallel and monolingual corpora. However, this is a bit awkward to use for typical use cases. So what would be nice to have is high quality comparable corpora with maximum linguistic usability and also good comparability. We are involved in two initiatives on comparable corpora. One is the International Comparable Corpus, which is a top-down approach, and the other is called European Reference Corpus, 𝗬𝗏𝗄, which is bottom-up approach. So we hope that these will meet at some point. The ICC was started by John Kirk and Anna Chermakova 3 years ago, and the aim is there to build a 1 million word corpora with controlled composition, roughly following the category system of the International Corpus of English, ICE. And text acquisition is already in progress for many European languages there. But I think John Kirk is not well at the time, so it's. But yeah, the basic idea for the 𝗬𝗏𝗄 initiative is that there are not many comparable corpora for European languages, at least, and but however there are lots of national and reference corpora: the American National Corpus, the British National Corpus, the Czech National Corpus, and so on and so on. So the basic idea is here to reuse the existing national and reference corpora and create some techniques for joining them virtually to comparable corpora, with each hosting center staying responsible for its own language. So the expected benefit, or the benefit we hope for, is that this approach is much more economical and scalable and sustainable than to create comparable corpora from scratch. The challenge is, of course, how to achieve comparability on these national corpora. And the basic approach is here to follow this virtual corpus approach we also use for DeReko, to draw comparable subsamples of the existing corpora using 𝗀𝗏's virtual collection feature, for example, based on metadata properties of individual text like topic domain, text type, and publication date, and so on. So comparable would mean something like equal token distribution with respect to these metadata properties. So if we apply this approach iteratively, start with a good mapping, and do some tests on this, and we can probably, or we know already that we can do this, and gradually improve the comparability. Not in general, I think this is not possible, but with respect to specific research questions, I think this is possible, and you can already define here different virtual controllable corpora, at least for Romanian, for the Romanian corolla corpus, the Romanian reference corpus, and hopefully also for the agency, for the Hungarian national corpus. We had 2 little pilot projects on this, which are almost finished, and we have done some first preliminary qualitative case studies at least, and we haven't got a fancy interface for this. To do this, we really use 2 windows of CoreUp and formulate the query for German here. On the one side, this is a study on correlates of complement clauses with assertive versus effective words, which is different in Hungarian and in German. And yeah, this is basically what we do now. And the quantitative things we tend to do with the R client. Okay, we've also done experiments with cross-lingual distributional semantics or cross-lingual words embeddings, like also proposed by Tom Mikolov already some time ago. But our results are not only superficially convincing. This is really might be good for automatic translation, but for us it was not so good. Maybe this is just because of us, or because our dictionary wasn't big enough. Okay, and that's it already. Thank you very much for your attention.